Hey guys, doing a new video on surface area and surface area of some of the curved shaped 3D objects. So the surface area of a 3D object is a sum of all of the areas of all the faces. You just have to be careful when you're doing these questions to count all the faces. They might be hidden or at the back of the diagram, because obviously the diagram is going to be 2D. Also, you have to be aware the question may explain that one of the faces might be missing and you should not be included. So like maybe a box has no lid, or a tin can has no lid, something like that. Or it might just be a hollow cylinder, so there are no circles at the ends. So there's a quick example here. A 60 centimeter by 60 centimeter box with no lid, to be painted only on the outside faces. What's the surface area to be painted? So it's only going to be painted on the outside, and it's got no lid. So always start with a diagram that will help you. What are the dimensions of this box? 60 by 60. Alright, so all 60. It's got no lid, and it's going to be painted only on the outside. Alright, and you still have to be careful. Remember, there's a face under the bottom as well. So area of one face is going to be 60 times 60. I think that's 3600, but just check. Yep, 3600 square centimeters. But how many faces are there? There's going to be one on the other side. 1, 2, 3, 4 in the back, and 5 at the bottom. Okay, so SA total is going to be 5 lots of the one face. $18,000 square centimeters. Why is that? It's because it's a cube. Cubes have 6 faces, but this one has no lid, and it's going to be painted on the outside. So 5 faces each of 3600 square centimeters is going to be 18,000 square centimeters. So that's just an example of things to look out for in the question. Always draw a diagram, it will help you. So now on to surface area of cylinders, spheres and cones. You'll find these formula anyway on page 193 of your textbook. But I just want to go over them anyway because you can't just add the faces together here. They have curved surfaces, so you really should use this formula. So the surface area of a cylinder is going to be the area of the barrel part, okay, the curved surface, plus the 2 end circles. Right, so the surface area is going to be 2 pi RH plus 2 pi r squared. 2 pi r squared is the 2 lots of end circles. 2 pi RH, well, 2 pi r is the circumference, okay, is the circumference of the circle, and then you're timesing it by h, because that curved part is actually going to be a really long rectangle that goes all the way around, connects back up with itself. So the length of that rectangle is going to be the circumference of the circle, and that's why it's 2 pi r times by h. There's no special explanation for the sphere. You could look it up if you wanted to. The sphere surface area, just plug it into that formula there. With a cone, the curved surface area is going to be pi times r times by s, and then you need to add the circular base as well. So to give you an example of doing the a cylinder problem, we've got a tin can here, and the top has been removed. Okay, find the surface area of the tin can below. The top has been removed, the outside I should say, because if I was being pedantic and I just said surface area, well, if the can's open, the inside would have an area too. So the outside surface area, so basically the tube, the cylinder, and the bottom face are going to be what we're working out here. So the surface area of a cylinder is 2 pi RH, that's the curved surface, which we're interested in, plus 2 pi r squared. The only problem here is we're only interested in the area of one of those circles because the top has been removed. That's 2 circles. Okay, so we need to change it a little bit for us. It's going to be surface area is going to be 2 pi RH plus pi r squared, because we don't need 2 anymore, we only need the 1 pi r squared. So it's going to be 2 pi times by the radius of 6 times by the height 15 plus pi times by the radius again squared. So remember, in your calculator, pi is second, then the hat symbol, the little arrow pointing up on the right side, about halfway down. So 2 times by second pi times by 6 times by 15. That comes to, the first part comes to 565.49 square centimeters, so 2 dp plus 6 squared times by pi comes to 113.1 to 2 decimal points centimeters squared. So 565.49 plus 113.1. So our answer to 2 decimal places is going to be 678.59 square centimeters to 2 decimal points. Okay, so that's an example of one of these curved surface area problems, and also considering missing faces. Just be careful, don't just chuck it into the formula straight away. Think about what it's asking first. So, yep, hopefully that helps you, and I will see you on the next video.